Good afternoon, everyone. I am Pranav Ashok Mahitkar, year mechanical engineering student at IIT Madras. So um, the project that I'm working on is wind and rain driven ambient noise layer. The goal of the project is to build natural acoustic baseline for the Indian Ocean region, so which will be part of a larger marine spatial planning toolkit, which is focused on underwater domain awareness. What are the gaps that we are trying to address, or what is the need for this project? So, the Indian Ocean region is one of the world's most spatial bodies of water, yet its underwater soundscape remains poorly understood. Most regional ocean planning treats underwater noise as purely anthropogenic problem, focusing almost entirely on commercial shipping. The natural noise floor, that is the noise generated by wind-driven surface waves and rainfall, is almost entirely unmapped for this region. So one might ask why this is even important. So it is important because without this baseline, it is impossible to assess how much excess noise vessel traffic adds and where biologically sensitive quiet zone exists or how the soundscape shifts dramatically between the two monsoon seasons. So this project addresses all these issues and provide a 3D ambient layer, noise layer, with a 12-month climatology delivered as separate wind and rain segments and which will be then integrated into the MSP tool. The stakeholders and beneficiaries. So who will be benefited from this project? So the answer to this is every actor responsible in the governance of the Indian Ocean. So like naval and defense forces. So it will provide them a scientifically validated natural acoustic reference layer essential for submarine operations, mine countermeasures, and maritime domain awareness activities in IOR. Hydrographic organizations. So it will help them for sea state forecasting, ocean climate products, and navigational safety assessment. Conservational bodies and e-NGOs can use this as a tool to identify seasonally shifting acoustic quiet zones, which are critical for noise-sensitive marine species, including baleen whales and dolphins. Marine spatial planners can use it as a plug-and-play ambient noise layer for the MSP toolkit. Scientific and research community can use the validated 12-month climatology for various research purposes, and this also enables shipping operators and port authorities to understand the natural acoustic variability of the IOR waters across monsoon season, supporting quieter routing choices and voluntary speed reduction programs. So what makes this project stand apart? So what's the unique contribution? So the first one is it is the first IOR specific natural noise baseline. Second is dual source separation, which means wind and rain are modeled independently, allowing users to isolate and analyze each source separately. Third is monsoon-aware seasonal climatology. The 12-month climatology is specifically designed to capture dramatic acoustic shift between the southwest and the northeast monsoon season. The fourth is it is validated against real hydrophone data. And the fifth is it is a plug-and-play integration into the MSP toolkit. Methodology. What are the steps that we are going to take in order to complete this project? So the step one is a thorough literature review. Going through the foundational works of scientists like Vance, Newston, Hildebrand, etc., in order to acquire knowledge which will be required for this project. Second step will be multi-data set acquisition. So we'll require weather data like speed of wind, precipitation rate, temperature and salinity profile, bathymetry, etc. Third will be spatio-temporal alignment. So we'll interpolate all data sets to a common master grid, which will allow us to compute sound speed profiling. The fourth is acoustic modeling. So we'll use the Hildebrand's empirical equation for the wind layer and Newton's empirical equation for the rain layer. And fifth part is the validation part. We'll validate the output of the model with real data of the Diego Gracia's hydrophone records. After applying P10 percentile filtering for stripping out the commercial shipping noise. And the final step is 12-month climatology, which will help us to capture southwest and northeast monsoon acoustic contrast. So in the conclusion, I would like to highlight that this project provides value on three different levels: ecological value, strategic value, and planning value by converting raw weather data into living acoustic map of the Indian Ocean, which will enable smarter, science-based and sustainable ocean governance across the Iowa. That is it from my side. Thank you.